So we're picking up with our application problems where we left off. We covered addition and subtraction in the first video, so the second one we're going to look at multiplication and division. Our example 5 says a comet travels an orbit whose length is 2.3 times 10 to the 11th miles. What is the distance the comet travels after making 15 orbits? So, like we talked about yesterday, we know this is a multiplication problem, but we want to make sure that we understand why. So, this one, we have our distance the comet travels, and then we have 15 orbits. So, I know I can add this up 15 times, but multiple additions is multiplication. So that's how I know that this is going to be multiplication. In this case, we would do 2.3 times 10 to the 11th times 15. Now, I want to rearrange these so that my 2.3 and my 15 are together, because that's the two pieces that I want to multiply. So I'm just going to regroup. So I have 2.3 times 15 times 10 to the 11th. I don't expect you to be able to do that in your head, so you are okay to use a calculator. For me, you may need to ask your teacher in your classroom. We could do 2.3 times 15, and we get 34.5. So I have 34.5 times 10 to the 11th. That's a great answer. I know it's in miles, but since we're working on scientific notation, I know that 34 is greater than 10, so I need to clean up this notation a little bit. So I'm going to move this one place, making 34.5 smaller, so I need to balance it by making my exponent larger. So we'll add 1 to our exponent, giving me a final answer of 3.45 times 10 to the 12th miles. Okay, before I talk about the next one great thing about these is that sometimes with multiplication, we have scientific notation times a regular number, and sometimes we end up with two scientific notations. So let's look at example 6. A hydrogen molecule is 1.5 times 10 to the negative 10 meters long. How long is a string of 1.3 times 10 to the third hydrogen molecules? So, we know the length of 1, and they want us to find the length of a lot. If we think about this, 10 to the third would be 1,000. 1 times 1,000. So we are looking for 1,000 hydrogen molecules. Again, this one is multiple additions, and we know multiple additions is multiplication. We know we're looking for this many hydrogen molecules of this length. So we're going to multiply those two numbers. So we have 1.5 times 10 to the negative 10 times 1 times 10 to the third. Now, I like to regroup to make this a little bit easier to work with. So I'm going to put my lead numbers together, and I'm going to put my tens with exponents together. So I have 1.5 times 1 times 10 to the negative 10 times 10 to the third. I know 1.5 times 1 is just going to stay 1.5. And then I'm going to use my exponent properties, 10 to the negative 10 times 10 to the third. This is our product rule. My bases are the same, so I'm going to add my exponents. So negative 10 plus 3 will give me a negative 7. So 10 to the negative 7. So the only thing I need to add right now are my units, and we have meters. So this says that 1,000 hydrogen molecules would be 1.5 times 10 to the negative 7 meters long. Okay. We are down to our last two problems, and these are division problems. So let's figure out why they're division, and let's work them out. The Earth has a diameter of about 1.27 times 10 to the 4th kilometers. The diameter of a dwarf planet is estimated to be 2.3 times 10 to the 3rd kilometers. About how many times larger is the diameter of the Earth compared to the dwarf planet? So there's that phrase that we talked about in our notes page, and it says, how many times larger? Okay, the times right here is our key. That's the difference in two different operations, but that's our word that tells us that we're looking to see what number we would multiply by, so we need to divide. Okay, how many times larger? When it throws in that word times, that's our hint, that's our clue that we need to divide. Since Earth comes first, it'll be Earth divided by the dwarf planet. I think these are my favorite problems to work because I get to line them up nice and neatly. So Earth is 1.27 times 10 to the 4th. So 1.27 times 10 to the 4th. And on the bottom, I'm going to put 2.3 times 10 to the 3rd. Okay, again, we don't expect you to be able to do this in your head, so I'm going to use my calculator. So 1.20. I'm typing. Try again. 1.27 divided by 2.3. Okay, so we get 0.552173, a lot of digits, so we're going to cut that off somewhere. Okay, so I took these numbers and I divided. That gave me 0.55. We had two decimal places here. So I'm going to use a couple of extra digits. So we're going to say 217. Okay, and then I'm going to take these two numbers. This is our quotient rule from our exponent properties. So we have 10 to the 4th divided by 10 to the 3rd. So we move it up and we subtract, and we get times 10 to the 1st. We do have a small problem though. We are not quite in scientific notation. So this number right here is smaller than 1, so I need to move my decimal so that it's between 1 and 10. So I'm going to move it one place. When I do that, it's going to make this number larger. So if I make this one larger, I need to balance it out by making this one smaller. So I'm going to subtract 1. That's going to give me 5.5217 times 10. And when I subtract 1 here, I'm going to get to the 0 power. So it does say about, so I would say that Earth is about 5.5 times larger than the dwarf planet. And I guess we need to write it. We need to put times larger. Okay. So, example 8, our last one, says the distance from Memphis, Tennessee to Portland, Maine is about 2.34354 times 10 squared kilometers. If Mavis drives half of this distance before stopping, about how far does Mavis drive? So our question here is about how far does Mavis drive. That part of the question doesn't really tell me anything. So I need to back up just a little bit. It says Mavis drives half of the distance. So that word, half, tells me that I need to cut this in half. We can cut it in half by dividing by 2, so that's my hint that I need to divide. This is one of the nice ones that this is one of the ones that we don't have two scientific notations. We end up with scientific notation and a regular number, which will be 2. So I have 2.354 times 10 squared divided by 2. Okay, again, we don't expect you to do this in your head. So 2.354 divided by 2. And I get 1.177. So 1.177. And then I just need to keep the times 10 squared. My distance here is kilometers. So if Mavis drives half of the distance from Memphis to Portland before stopping, then she would have driven 1.177 times 10 squared kilometers. With our application problems, you can have any of our 4 operations, and sometimes it's even just comparing 2 numbers. The key is to look for those words that lead us to what operation to do, and those words are typically going to be in the question at the end. Hopefully this will help you get through our application problems. Good luck. Have a great day.